Hello. We are going to talk about mensuration. Now, mensuration is about measuring of areas and volumes. So let's start by talking about length. In order to calculate areas, we need to start with the length of a shape. So the units of length that we normally use are cm for centimeters, m for meters, km for kilometers, mm for millimeters. So these are the units that you often see, right? So millimeter is the shortest, centimeter is longer, meter is maybe that long, and kilometer is a lot longer. Now what we need to do now is to start by knowing how they are related together. Okay? Now, 1 millimeter is what you would see on your ruler. If you look at your ruler, the smallest interval is usually 1 millimeter. So, and 10 millimeters gives you 1 centimeter. So let me write that down. 1 centimeter will give 10 millimeters. And 1 meter, if you have a meter rule, a ruler that is 1 meter long, you'll find that there are 100 centimeters in this ruler. So 1 meter is 100 centimeters, right? Now 1 kilometer, right, as we normally understand it, 1 kilometer is 1000 meters. So these are the relations that you might be familiar with, and that is used quite often in everyday life. Now, we need a more systematic way to learn these units if we want to do proper mathematics. So the way to learn the relation is to understand what we call the prefixes. Now, this refers to the M here, the C here, and the K here. Now, if you look at this, all of these units have M. Right? The M in these units stand for meters. Now, the other letter there stands for something else. So, for example, the M in the millimeter stands for a certain factor. So let me write this out. The M there stands for milli, and milli means 1 over 1000. Right, the C there stands for centi, and centi means 1 over 100, and the K there stands for kilo, and kilo means 1000. So these are really what the letters here mean, right? And once we remember the meanings of these letters, of the M in millimeter, the C in centimeter, the K in kilometer, once we know this meaning, we can change from one unit to another more easily. And we often have to do that when we need to calculate lengths and areas in maths. So let's use this to write down the lengths in meters, in terms of meters. So if I say 1 mm, so as we understand it, the milli means 1 over 1000. So if you have 1 millimeter, it means 1 over 1000 of a meter. Alright, so that's exactly what it means. And if I have 1 centimeter, centi means 1 over 100. So centimeter means 1 over 100 of a meter. Kilometer, 1 kilometer. So because kilo means 1000, therefore 1 kilometer means 1000 meters. And it's quite useful to remember the meanings of milli, centi and kilo, because we use it, not only because we use it quite often, but because the same letters are used for other types of units like grams. Right? You know of grams and kilograms and milligrams. So that's what these factors, alright, are what those names mean. Like milligram means 1 over 1000 of a gram, kilogram means 1000 grams. So it's really useful because these letters get repeated in many different types of units. Okay, now let's make use of this knowledge to practice some conversion. Right, before I do that, I should mention one more of these prefixes that is less commonly used, but you do see it. It's called deci. Okay, deci means one over 10, and the letter is D. So for example, if I say 1 dm, D means 1 over 10, so 1 dm means 1 over 10 of a meter. Now, we don't use dm so much when we measure length. Alright, you see more often millimeters, centimeters and kilometers. But we do use dm when we measure volume. Well, dm is length, not a measure of length, not volume. But when we measure volume, we often use 1 dm cubed. And 1 dm cubed is actually 1 liter. Alright? Alright, but we hear of the unit liter more often, but we do use dm cubed as well in science. Okay, so let's go on to do some exercise. .7 kilometers. Now, suppose I want to change this to meters. I want to know how many meters is 2.7 kilometers. So the way to do it is to, let me just write a blank there. Alright, so that's the question. 2.7 kilometer is how many meters? So in order to do such a conversion, that's what we call this kind of problem, because we are converting between the units. So we are doing a conversion. In order to do this kind of conversion problem, we need to know the relation between kilometer and meter. So the first thing that you should do really is to write down the relation between 1 kilometer and 1 meter. So let's do that first. So 1 kilometer. Now if you remember that kilo means 1000 and 1 kilometer means 1000 meter. Right? So if you have 2.7 kilometer, the way to do it is to say that it is the same as that is to say that it's the same as 2.7 times 1000 meter. Alright, because 1 kilometer is 1000 meters, so if you have 2.7 of a kilometer, it means the same thing as 2.7 times 1000 meter. So once you write this down, once you realize this, it is just a simple multiplication. And 2.7 times 1000 is 2700 meter. So that's the answer. That's how we do conversion. Let's try another question. Now let's do 71 millimeter. Now I want to convert 71 millimeter to meters. So how many meters are there in 71 millimeter? Now it's the same idea. In order to do this, you must first write down the relation between millimeter and meter. Okay, so 1 millimeter is equal to how many meters? And if you remember that milli means 1 over 1000, then 1 millimeter is 1 over 1000 of a meter. So therefore 71 millimeter is 71 millimeter is 71 times 1 over 1000 of a meter. So there we have the answer. You just multiply the two and you get 71 over 1000 over meter. There. So that's how we do the conversion. Now so far I have taken some units like kilometer and meter and converted to meters. Now let's do the opposite. Let's try and convert some numbers from meters to millimeters, for example. Okay, let's say I have 28 see, 28 meters, and I want to know how many centimeters there are in 28 meters. So like before, we need to write down the relation between meters and centimeters. Now we know that 1 centimeter, okay, we know that centi means 1 over 100. So 1 centimeter means 1 over 100 of a meter. Right. Now in order to convert from meter to centimeter, it is more convenient if I know how many centimeters there are in 1 meter. That means it is more convenient if I know 1 meter is equal to how many centimeters. Because if I know this number of centimeters in 1 meter, all I have to do is to multiply by 28 and I'll get the answer. So, what is that? Now, I know that 1 centimeter is 1 over 100 of a meter. So therefore, 1 meter is 100 centimeters. Okay? Now, one way to think about it is that you can imagine 1 over 100 of a meter means that you take 1 meter and you divide it into 100 parts. So each part is 1 over 100 of a meter, and that's a centimeter. But that also means that in that 1 meter, there are 100 of these parts. There are 100 of these centimeters. So therefore, 1 meter contains 100 centimeters. So that's one way to think about it. You can think about it physically or like a picture. Another way to think about it is to think about this like an equation. You can multiply both sides by 100. So 100 times 1 over 100 is 1. That gives 1 meter. And 100 times 1 gives the 100 cm. So either way, from this relation, we can see that 1 meter is 100 centimeters, and if you have 28 meters, that would be 28 times 100 centimeters. Alright, because 1 meter is 100 centimeter. So now that we have 28 times 100, we can just multiply that to give the answer. 2800 or 2800 centimeters. So that's how we can convert from meter to centimeters. Okay. Now I'll move on to areas. Now let's start with a simple area, a simple shape. A rectangle. Now suppose that this rectangle has a length of 3 centimeters and a height of 2 centimeters. Then we can find this area by taking the length times the height. So that's a formula. That's the way to find the area. So let me write that down. Area is equal to length times the height, or sometimes you say length times the width. Okay, and if you do that, the answer is 2 cm times 3 cm okay, and 2 times 3 is 6. But what is the unit? Now, you may already know that the unit is centimeter squared, but now that you have learned algebra, if you have not, take a look at my earlier videos. We know that it is centimeter squared because we have centimeter times centimeter. Right? So it's like in algebra when you have two symbols. Right? cm is like a symbol. So symbol times symbol is symbol squared. cm times cm is cm squared. So that's what we do in algebra, and that's the reason why we have a squared there. So cm squared really means centimeter times centimeter. Alright? So, just for convenience, we often, instead of writing a word equation like this, we often use symbols to make a formula for the area. So for example, in this case, I might represent this 3 centimeter by L and the 2 centimeter by the height, for example. So, and then the area by A. So I can also write this word equation as A is equal to length times height. So LH. Okay? And we treat this like we treat symbols in algebra. So if you have LH without anything in between, that means that it is L times H. So that's how we find the area of a rectangle. Now we need to learn the formula for finding the area of a few different shapes. So let's move on to the next one. Now the next simple shape looks like this. So it's like a rectangle that is tilted, right? Now this shape has two sides, two opposite sides parallel. So these two sides are parallel and these two sides are parallel. Now a shape like this is called a parallelogram. So that's quite a long word. Let me write that down. It's called a, start with parallel, right? Parallel means like these two lines go in the same direction. And then logram, parallelogram, parallelogram, parallelogram. Okay, 3 L's there. L, L, and L, 3 A's, A, and A, and 2 R's. Long word. Right, how do we find the area of this parallelogram? Suppose that this bottom side, this base here, is 3 centimeters. Okay? Now, and that this height is 2 centimeters. So that's the information we need to find the area. We need to know the base and the height. Now the height, be careful, is the vertical height. That means you go straight up. So you would draw a line that is perpendicular, that is at 90 degrees to the base, from the base to the top, and the length of this distance is the height. You must not use the slanted height to find the area. Okay, and the formula is the same as for a triangle. Base times height. The area of a parallelogram is the base times the height. So in this case, just 3 times 2 centimeters. 3 cm times 2 cm equals to 6 cm squared. That's the area. And we make the word equation simpler by using, again, symbols to represent these quantities. So let me call the base B, the height H, and the area A. So A is equal to B H, base times height. B H is B times H. So this is a simple formula to remember. A is equal to BH, or it's quite easy to remember, area equals to base times height. So that allows you to calculate the area of a parallelogram. Now the next shape we want to look at is the triangle. That's a triangle. Now you may already know the area for this, but I'll go through it anyway. Suppose that the length of the base is 3 centimeters and the height height means the vertical height, well, if the base is horizontal, is if you draw a line from the top to the bottom, a line that is at 90 degrees to the base. Now suppose this is height is 2 centimeters. Okay, then the formula for finding the area of a triangle is area is equal to half times base times height. That's the formula. So in this example, it would be half times base is 3 centimeters times the height, which is 2 centimeters. Alright, and the answer is half, and the 2 cancels. Half of 2 is 1, so the answer is 3, and cm times cm squared is the units of the area here. So that's the area of a triangle. So again, we can make up some symbols to have a simpler formula. You would often call this A equals to half B H. So B for base, H for height. Half base times height. That's a triangle. Now the next shape we are going to look at is the trapezium. Now that's another funny name. A trapezium is a shape that has 2 parallel sides only, and the other 2 sides do not have to be parallel. They can it does not have to be symmetrical. So let me draw it this way. Okay, so 2 sides parallel. So that's called a trapezium. Let me spell that. Trapezium. Trapezium. Okay, now in order to find the area of a trapezium, we need to know the length of each parallel side. So let's say this is 5 centimeter and this is 3 centimeters. Okay, and we need to know the distance between the 2 parallel sides. The distance means that you draw a line at right angle to each side, and the distance along that line is the distance we need. So let's say that's 2 centimeters. Now, what is the formula to find the area of a trapezium? Okay, let me write down the word equation. It goes like this. Area is equal to half times Right, it goes like that. The area is equal to half of the sum of parallel sides times the height. So these are the parallel sides, the 5 cm and the 3 cm. So the sum of parallel sides means that we must add the 3 and the 5 centimeters together. That's the sum. And the height here is the 2 centimeters. So I must take half times the sum of those two, which 3 plus 5, which is 8, and then I must multiply by 2. So let me write that out, write the whole thing out first. So I must take half times, okay, I must add 3 to 5. Right? But I should add 3 to 5 first before I multiply by half or by the height. That means that I have to be careful to put brackets around the 3 plus 5. Otherwise it looks like I should do the half times 3 first before I add the 5. That's wrong. So to avoid this mistake, we need to put the bracket. We need to make sure that we add the two parallel sides first before we do any multiplying. So times the height is the 2 centimeters. So that's what it looks like. Okay, and we know that we must do the bracket first. So 3 plus 5 is 8. And we have that. And half of 2 is 1. So these two cancels. And we have 8 as the answer. 8 cm squared. So that's how we calculate the area of a trapezium. And let's make a simple formula for that. Let me call the area A. Now the parallel sides, let me call that one side letter A and the other side B. Okay, so, and let me call the height H. Right, so the formula looks like this. Half sum of the parallel sides, that would be A plus B, with a bracket to make sure that we add the A and B first, times the height, which is H. So that's the formula. Alright, I can leave out the times because in algebra you can leave out the times. If you have two symbols next to each other, it means that you multiply. Okay, so that's the formula for a trapezium. Just moving on. Right, the next shape is a nice one. It's a circle. Okay, my circle is not very circular, but it's supposed to mean a circle. So let's say that this is a circle. Now a circle has a center. Okay, there are some names about the different parts of the circle we need to learn. So the point at the center is called the center. Right. Now from the center, if I draw a line to the side of the circle, the length, well, this line is called a radius. It's called a radius. Alright. And we have the area inside. So how do we find the area? Now the formula for this, let me start with calling the radius r. So there is a formula for this. The formula for the area, the area, let me call the area A, is equal to pi r squared. Now, pi is a number, it's a special number. Pi is equal to 3.14 and so on. Okay, it's in decimal, it's a number where the decimal keep going and going without end, right? And there is no pattern to the numbers in the decimal places, so we call this kind of number an irrational number, and you normally find this number on your calculator. Okay, so for now let me just take it as 3.14 approximately. So if I want to find the area of this circle, what do? Now suppose that this radius is 2 centimeters, right? In order to find the area, I can use this formula. So the area will be pi r squared. Now pi r squared means that I should take pi, which is roughly 3.14, times r squared, and r is 2 centimeters, so that would be 2 centimeters squared. What is 2 centimeters squared? Two centimeters squared is really 2 times 2 centimeters. Okay, so you can use your calculator to find the answer to this. 3.14 times 2 times 2, and you can get an answer. And the units, the unit for area, in this case centimeter squared. Okay, so that's how you find the area of a circle. But there is another part of the circle that we also often need to find, and that is the length of this thing, of this side around the circle. Now the length of this side, or this circular side of the circle, also has a name. It's called circumference. So that's another long name. So circumference, right? Now let me represent that by the length of this circumference by the symbol c. Now there is a formula as well for finding the circumference, and that formula is c equals to 2 pi times r. And using this formula, we can find the length of the side of the circle. So let me write this down. So what we are actually calculating is, for this example, is 2 times roughly 3.14, and r is the 2 centimeters. So 2 times 3.14 times 2 centimeters, and you can calculate that in your calculator and get the answer. So that's the formula for the circumference of a circle. Now, there is another shape related to a circle that we often see. So let me sketch out, right, that's sort of the outline of a circle. Now, we could have something like this. From the center of the circle, if I draw two lines to the circumference, and I draw the curve along the circumference, we get a shape like this, a shape that looks like a piece of cake. If you have a circular cake, you normally want to cut it up into slices. That's the shape of, that's the usual shape of a slice of cake that you eat. Right, apart from the rectangular kind of cake. But this piece of cake, this shape here has a name. The name of this shape is a sector. So if you cut this shape out from a circle, alright, starting from the center, cutting two straight lines out from the center, this shape is called a sector. Now, and we can also find the area of a sector, and the way to find it is that you have to know the angle. Right. Now, in this example, let's say, let's say the angle here is 30 degrees. Now 30 degrees is this angle, and if you go all the way around, alright, if you have an angle that goes all the way around, then that's 360 degrees. Okay, so if I have a line there, and if I have an angle that goes all the way around, okay, an angle like this is 360 degrees. Right, so how do I find the area of the sector? The way to do it is to think of the sector as a fraction of the circle. So if this angle is actually 360 degrees, alright, that means that the area of the whole circle is what you get. So the area of the whole circle is really a sector with an angle of 360 degrees. But if we have only 30 degrees here, we have a fraction of that. Alright, 30 is a fraction of the 360 degrees. So the area of the sector we can find by taking the angle of the sector divided by 360 degrees and then multiply by the area of the circle. Alright, that's the sector area. So the sector area is the fraction right? The angle of the sector divided by 360 times the area of the circle. So that's the formula. So for example, if this length is 2 cm, if the radius is 2 cm, we can find the area using the formula for the area of the circle, which is pi r squared, and in this case r is the 2 centimeters, so we can do 30 over 360 times, and pi is about 3.14, or you can use the exact the precise value from your calculator, times r squared is 2. So, and then you can use your calculator to find this answer. Now let's make a formula for this. So in this case, the area, let me call the area A, that's the area of the sector. This is equal to, now let's give the angle a symbol. So the symbol is usually this funny curly thing called theta. It's a Greek letter, a letter from this country called Greece, and it's a Greek letter, and it's pronounced as theta, T-H-E-T-A, theta. So we write it like an O but with an additional line across the center. So that's the symbol we often use for angle. Alright, so that's the 30 degrees there. That's the theta. So if I want to make a formula, I can say the angle of the sector over 360 times the area of the circle. And the formula for area of a circle is pi r squared. So there we have a formula for the area of a sector. Right. Okay. Now, one more thing that we may also need to find. So let me first clean this. Okay, so 2 is R. Okay, the other thing that we might also need to find is the length of the curved side of the sector. Now, this length here is really a segment, that means a small part of the circumference, right? So this curved side here has a name. It is called the arc. So that's the arc of the circle. Now, we can find the length of the arc. The way to do it is to again think of the sector as a fraction of the whole circle. So the sector is 30 degrees out of the 360 degrees, which represents the whole circle. So in the same way, we can think of the length of this arc as a fraction of the length of the whole circumference. So therefore, the arc length is equal to 30 degrees divided by 360 times the circumference. Okay. Fraction of the circumference. So how do we calculate that? Right, we need the formula for the circumference, which is 2 pi r. And r in this example is 2 centimeters. So therefore, we have fraction times 2 times roughly 3.14 times the radius 2 centimeters. And then you can press your calculator and find the answer in cm. So that's how we can find the arc length. So again, we can write down a formula for this. So let me represent the length of this arc by symbol S. So S is equal to, now 30 degrees over 360, so 30 is the angle theta. So theta over 360 times 2 pi r. 2 pi r. Right? Now I've put a little dots there. Now that's what we also do sometimes in algebra to represent multiplication. So if you have two symbols with nothing in between, like pi and r, it means pi times r. But if you have a dot, the dots between two symbols also means multiply. And sometimes I put a dot because the two sides are too complicated. Like in this case, it's not just one symbol, but it's a big fraction. So putting a dot there makes it easier to see. Right? Or I can always put a times there. Right? I can do that too. Okay, so that's the length of an arc. Now before I finish off, let me say something about the triangle again. There's something slightly tricky about the area of a triangle. Now, we have seen that if I have a triangle like that, I can find the area using this formula, half base times height. So half of 3 centimeters times 2 centimeters. Okay, so that's okay. Now, what if I have a triangle that looks like that? Right, a rather slanted triangle. Now the base, this could be the base. For example, this might be 3 centimeters as well. So that's the base. But what is the height? Right, in the first example, the height is quite obvious. I just draw a vertical line from the top to the base, and the length of that is the height. But for this very slanted triangle, if I start from the top of the triangle and I draw a vertical line down, there is no base. Now the way around this is to extend the base. Meaning, I don't mean making the base longer, but I mean going to the base, the 3 cm, and drawing a line, making the line longer along the base. Okay, the actual base is still 3 centimeters, of course, but just draw a line along the base so that it extends further. And then draw the vertical from the top to this extended line. And call that the height. So that's my height there. So let's say that's 2 centimeters. So now that we have the height, we can use the same formula again to find the answer. So for example, in this very slanted triangle case, the area would be half times the base, 3 centimeters, times the height, 2 centimeters. So the answer is 3 centimeters squared. So that's the special case for a triangle, for a very slanted triangle. We shall stop here for this session. Thank you.